we need to stay sharp in time, and I would like to present the next colleague of mine. He's a specialist in Simulation Center for Process Automation. As a matter of fact, he's heading this department, and he's talking about how to boost your plant efficiency with virtual commissioning and how you can benefit from virtual training environments with SIMIT. Welcome up on stage, Dr. Matthias Oppelt.
Yes, thank you very much, and warm welcome from my side to the SPS 2017. We have heard about a nutrition control just in the presentation before. I bring the next fancy thing to you, a reset button. So as you all know, reality, actually there doesn't exist a reset button, and you might all know the situation. You sleep long in the morning, you drop your cup of coffee, you have to stop at each red traffic light, you miss your first meetings, and you say, oh, if I could reset that and start again, wouldn't that be great? To start over again? Maybe I cannot have that solution for you for the whole life with a reset, but how do I can bring something, maybe something which is similar like a reset button for engineering, training, commissioning to you? So for the automation engineers, does there something exist like a reset button? And if you think about your commissioning phase, what are challenges and questions you typically have? How can I decrease my commissioning time to the minimum possible amount? How can I boost my plant productivity? How do I reduce all the risks by having that untested software which I connect to the real production machines? How do I manage that? And last but not least, what's about my operators? How do I train my operators who have never dealt with that plant, with that machine before, in an efficient manner that they can run the production safe and efficiently? And there's one solution for it. And this is testing and optimization in a completely virtual environment. And this is still pretty abstract, so I would like to take you on a small journey into that virtual environment. How does it actually look there? So let's go into that virtual world. And our virtual world starts with a virtual plant model, a virtual plant in SIMIT, in the SIMIT simulation platform. And you can connect that virtual plant to our controller levels, which you can see here all over the booth, like an S7400, like an S7-1500. Connect your real automation system to your virtual plant and control actually with your real automation system the virtual plant. Wouldn't that be great to have a virtual plant which ensures you to test out your original automation implementation? And that's available. You could even go one step further into the virtual domain and virtualizing also your controllers. We talk then about software in the loop. We have a virtual controller, SIMIT virtual controller, which is designed for a S7-300, 400 controller series. And we have the new release PLC Sim Advanced, which is a S7-1500 emulation software. And you can also connect that to your virtual plant, which you have modeled in SIMIT. And even one step further is possible that we have also open interfaces like OPC UA, which you can use to connect it to any other tool. So maybe there's some portion of a virtual plant available in another simulation tool. Make use of it, reuse it, connect it into SIMIT, and build your full-blown virtual plant with that. Or use OPC UA to connect to any other controllers you have and you need to test. So I was talking a bit about the virtual plant and how that is a core piece of virtual commissioning and testing. But how do I get that virtual plant? My task is to build and deliver an automation solution for a machine, for a production machine, for a plant. So I don't want to waste a lot of time with just doing simulation modeling, even though it's a great job. So we can make use of already existing information which could be stored in planning tools like Comos, for example, for the process industries. We could make use of automation engineering data, which could be stored in SIMIT PCS7 or in TIA portal, and import that information into SIMIT to create most of your virtual plant completely automatically. And if you have then your virtual plant, you connect it to your real automation, you test it out, and when you're done with testing and you say, okay, my software is error-free, I've proved that, then I switch over to the real production site, I start the facility up, and that usually smoothly and without any trouble. And you could consider virtual commissioning to be one final step for the real production, but you could even go a step further there, to use simulation continuously throughout your engineering process. So make them parallelize both of them, and the maximum benefit is then that you fix an error immediately after you implemented that one. So we all know nobody actually does an error, but in software engineering, there might end up some flaws in your software which you would like to identify as soon as possible, because as earlier as you erase that flaw, as cheaper the costs are. So if you have to shut down the plant later to sort out your software and correct that, that's really a fortune of money which you have to invest shutting down a plant. So you better use it continuously throughout your engineering, build your virtual plant, implement your software against the virtual plant, and test it out simultaneously while you engineer. And as I mentioned in the beginning, you might have also the question about how do I actually deal with my new operators, with operators who have never controlled that plant before. You can also use your virtual plant to do operator training in a completely virtual environment. And the large benefit is that the virtual plant can be even available before the real plant is actually available. So you just think about a digital twin. The virtual plant is a digital twin. So even twins, there's an order in terms of birth. So you can think the virtual plant, it's a twin which is actually the firstborn. And then you can train your operators against that. And also a good benefit about that digital twin, you don't need hardware for that. It's completely digital. So you have no machinery, no equipment, and also no risks to damage that. And you can safely train your operators also in very critical incident situations, which you would pretty sure you don't want to tease that critical situations on your real plant, on your real machinery, because you jeopardize that damage. So it will increase your reliability, productivity during engineering and during production. So during the operations phase, the operators have to interact with the plant, and therefore a good trained operator could be very valuable to your operations. And that does not even apply only for simple machines or simple plants. It goes up and scales up all the way to very complex plants. And finally, you have, with applying that virtual plant technology based on SIMIT to your engineering and operations process, you have minimum possible project times. You certainly avoid shutdowns due to misoperations. You have, therefore, much higher safety and security level on your production side, which finally leads to an increased availability. And production availability, reliability is actually the key for success. And thinking about a plant is some kind of a living organism which could constantly change. You do some migration, you do some extensions. Also your digital twin, your simulation model in SIMIT scales with that. You can test out your migrations, your add-ons in your virtual world before you also take that to the real production. So as I was talking about the benefits of a virtual plant in connection with our automation solution, it can really deliver benefits across the whole life cycle. So if you start early, you gain the maximum benefits during your engineering. Then you take it into commissioning, you shorten your commissioning times, and you bring it into operations and have best trained operators. And now you would wonder, maybe one of you thinks, okay, I have a machine, I maybe have a production line, I do maybe have a chemical plant or pharmaceutical plant, I might have a power plant. For who does it actually apply? There's a simple answer that applies to all of you. Everyone who is doing automation could benefit from the solution we are presenting here, a virtual plant in SIMIT. And all the industries you see here, we have done projects with. We have also some experienced, knowledgeable colleagues who can support you in building up your virtual plant, or you do it on your own. So having virtual commissioning operator training in one environment, connecting that to real controllers called hardware in the loop, to virtual controllers, software in the loop, even open interfaces with OPC UI, and applying that across technologies. All that is combined in one product portfolio, which we call SIMIT. And doesn't that come pretty close to what I see as a reset button for the automation engineer? So that's quite cool. I was talking about the virtual world, a virtual plant, but this actually delivers real benefits. So I don't want to earn virtual money, I want to earn real money. And first of all, I can faster and smarter engineer. So I'm being much more efficient. I have a commissioning time shortening perspective, and clients who actually use that, or users using that for virtual commissioning with SIMIT, they say 30 to 60% savings in my commissioning time is certainly possible. And you just imagine commissioning is always on the critical path, so shorter commissioning, faster time to production, increased availability. And last but not least, all that leads to lower costs and most as efficient engineering and operations of your machines and of your plants. And now I would like to invite you. You can see us at the booth number 87 and come in closer interaction with Art and see what kind of reset is in it for you. So thank you very much.